Welcome back to the course, Multi-Layer Neural Network Training and Testing Implementation. In this lesson, we will work on an exercise using the University of California, Irvine's Machine Learning Repository, Breast Cancer, Wisconsin Diagnostic Dataset. Looking at the overview of the exercise, we'll first discuss the description of the dataset. Then we will briefly discuss the contents of the exercise folder. Next, we will discuss the steps involved to complete the exercise. Then, you will perform the exercise. And lastly, we will review the exercise. So now let's take a look at the description of the dataset. Again, this is the University of California, Irvine's Machine Learning Repository, Breast Cancer, Wisconsin Diagnostic Dataset. Each record in the dataset contains 32 attributes. The first is the ID of the record. The second is the diagnosis. And the remaining 33 are real-valued input feature values. This is a classification prediction problem where the diagnosis value is the label M or B. M stands for malignant or positive, and B is benign or negative. The data file contains 569 records. The exercise folder contains an empty starter folder within which you can store your files, starting with the dataset content files, and a completed folder contains the files I generated in solving the exercise, which you can compare to your own. The steps in the exercise are the following: download the dataset, generate a samples file, generate a test setup file, and lastly, run the neural network using the test setup file. The first step is to download the dataset. This is the URL to the dataset. Navigate to this URL and click the download button to download the dataset. After the download is completed, uncompress the contents. If you look inside the contents folder, you'll see two files, wbc.names, which contains the description of the dataset, and wbc.data, which contains the 569 records, each consisting of 32 attributes. The next step in the exercise is to generate a samples file. I suggest you load the data file into Excel or Google Sheets so that you can process the raw data file to produce the samples file, which will likely be a comma-separated values file, since that is what the data file is. As we discussed when analyzing the source code, a record in the samples file consists of n number values, which are the inputs, followed by m number values, which are the outputs. Therefore, each row or record of the resulting samples file will first consist of 30 inputs, which are the 30 real-valued input features, possibly pre-processed to normalize their order of magnitude, followed by two number values, which are the outputs represented as a binary class vector. Nominally, I recommend using the value 1 for the class label M and the value 0 for the class label B. The next step in the exercise is to create the test setup file. I would recommend that you copy the test setup file from one of the file sample type dataset, such as the Succinctly, Iris, or Wine dataset, and rename the file to wdbc.json. These are the values in the test setup file that must be changed to match with the dataset. In particular, note that you have to change the number of outputs value in two places, one with the last layer configuration and the other with the file samples generator definition. The last step is to actually run the neural network with the test setup file. To run the neural network, use the command line shown here, which is the name of the executable followed by the test setup's relative file path. Now pause the video and perform the exercise. Let's now review how I performed the exercise so that you can compare it to how you solved it. So first I'm going to navigate to the dataset URL. Then I'm going to click on the download button. I'm going to open the downloads folder. I'm going to extract the files. Then I'm going to take the contents, which are those two files, and I'm going to paste them into the starter folder. So now we're going to create the samples file. To do that, first copy the .data file, paste it, and rename it to wdbc-data.csv. Say yes, we want to change it. Then what you want to do is you want to open up a Google folder, Google Drive folder, and you want to paste that. This is if you don't have Excel. I don't, so I'm going to do it this way. After it's completed the upload, I'm going to say open with Google Sheets. And after it's open, I'm going to, and here we see the data file with 569 records. And then what I'm going to do is I am going to create a new sheet. I'm going to rename it WDBC. And here what we're going to do is we're going to go get the inputs first. So I'm going to say equal, then go back to the data and click here. And I'm going to say divided by 1, and I'll explain why, because what we are going to need to do is pre-process these values so that they're of the same order of magnitude. So when you create a new sheet, it comes with 26 columns. So we have 30 input values and 2, so we're going to have to add 6 columns. And so I'm going to say insert 6 columns to the right. And then what I am going to do is take this number, this cell right here, and bring it all the way to the, have 30 values. And then I am going to do Control R, and that's going to get me the all the values. So what we want to do for each here is divide it by the order of magnitudes. In that case it was 10, this is 10, this is 100, this is 1,000, and I'm going to skip forward so you don't have to watch all of this, but you do this. For this one right here, it's a 0.1, so we're going to divide by 0.1. Same thing here, 0.1. Okay, so now I'm going to skip ahead until I'm done. Okay, so when we're done, they're all going to be the same order of magnitude, roughly. And then what we're going to do is we have to go and create the output values. And again, I said this is going to be a binary class vector. So what you want to do here is say equals if, and then we go back to the data file. If this is equal to M, then we're going to put a 1 there. Otherwise, we're going to put a 0. Okay, and this one we're going to say if, go back to here, this is equal to B, then we're going to put a 1. Now we're going to put a 0. Okay, so here we see our binary class vector. So we have one processed row. We're going to select that, and then we're going to page down to 569 here and say Control D or down. So we're going to copy the formulas, and we're done creating the file. Then what we need to do is go into File, say Download to comma separated value. Then we're going to open up the folder. We're going to cut it from here and bring it into here, and then we're going to name that one WDBC dot. So if we open that with, let's say, a text editor, then we basically see that we have the 30 inputs and then the binary class vectors for all the 569 records. And we're done creating the samples file. So now we want to create the test setup file. So as I mentioned earlier, what we probably want to do is go get one of the ones from the data sets. Just pick any old one. We can pick succinctly. We'll copy this one and bring it back into the starter here, and then we'll rename it to dbc.json, and then let's open it up in a text editor. And so we need to change the number of inputs, and since 30, let's just say 10 for the number of neurons this layer, and we have 2. You have to specify the number of outputs in 2 places at the last layer, and then also in the file samples generator definition. So the file that we just created was wdbc.csv, and as I said before, we have to set this to true, because in this case the files are not randomized, so we are going to randomize them. Other than that, we can leave the rest of the values the same. So if we save that and we close our text editor, we're done. So the final step in the exercise is to actually run the neural network with the test setup file that we just created. To do that, go to your distribution folder and enter the executable name as you see here, and then the relative file path to the test setup file. And so when we say enter, it's doing the training and then produces the test outputs. You can see 114 tests were performed, and overall prediction accuracy was 95.6 this time. We run it one more time, so we'll clear, run it again, and this time we got a prediction accuracy of 93%. So you see, every time we run it, we're going to get potentially different results because of the values that get set for the weights and biases and how the samples are generated and allocated to the training and testing sets. So that concludes the exercise.